Hello friends, welcome in Cadence tutorial. So in this lecture series of Cadence, in this video I am going to explain about the ID versus VDS plot of PMOS. So for that I am going to create a PMOS cell view. So in file, go to new, then in cell view again go to Cadence tutorial library, and in that I am going to change this cell name as PMOS characteristics. Okay, now this is the workspace of Cadence. So now I am going to instance PMOS. So for that I am going to press I, then go to GPDK 180 library for fetching PMOS. So GPDK 180, then in GPDK 180 type PMOS, so you will get PMOS, then go to its symbol. So its length is 180 nanometer, total width is 2 micrometer, finger width is 2 micrometer. So you can change the width accordingly, but you can't change the length because length is once defined, then it can't be changed. So I'm going to hide it. So this is the PMOS. Now for analysis of this PMOS, I have to give the drain voltage and gate voltage to this PMOS. So for doing its parametric analysis or its ADE L launch, first I am giving the gate voltage. So press I, then go to analog library, and in analog library you will get DC source. So select VDC, and this is the DC voltage source. So I am giving the DC voltage 1.8 volt here, and then hide this. So this is the gate supply voltage of PMOS. So I think you will be familiar about the PMOS IV characteristics. So this is the gate voltage, which will be negative here in this case, because the source of the PMOS will be connected with ground. So why this negative voltage is required? Because you know the VTH of a PMOS is basically negative. So the PMOS will turn on only when the gate to source voltage is lower than its VTH. Okay, so again press I, then go to analog library, then select ground, and this is the symbol of ground. So you can rotate it. So I'm going to rotate it. Okay, so this is our ground. Now I have to connect the ground of this DC voltage with, I'm selecting the upper voltage of the DC voltage with ground, so that it can give minus 1.8 volt to this drain. And then again the source of this DC voltage, this PMOS, is also connected with the ground, and the body of this PMOS will be connected with 1.8 volt. So it is going to connect with this. Okay, now I have to given the drain voltage to this PMOS. So again for that I am going to copy this voltage source. So this DC voltage source is going to be copied. Now connect this drain of PMOS with the negative terminal of this DC voltage and the positive terminal of this voltage source with ground. Okay, now this is the PMOS schematic for its IV characteristics. So if you have any doubt, go in theory of the PMOS IV characteristics. So after making this schematic and circuit, I am going to check and save it. Then go to launch and go to ADL. Then here select transient time. So I need to do its DC analysis because IV characteristics can be only seen on DC analysis. Then I have to select the component which I want to see on x-axis. So actually I want to see ID versus VDS plot, so I have to select VDS. So here select component and then go to schematic and click on this drain voltage, then select DC voltage, then click on OK, and then again go to choose parameters. Now you can see here it is DC and it is V1. Now give its start and stop durations of voltage. So I want to see this plot from VDS equals to 0 to 1.8, then click on OK. Now after doing this, go to again ADL launch, then right click on output section and go to edit, then from design select the output node which you want to see. So I want to see the drain current of this PMOS. So I have to select its drain voltage, drain current or drain node, but the drain node of, if you select the drain node of this PMOS, it will give you the negative current. So for our reference or for our conventional IV characteristics of PMOS, the actual characteristics of PMOS is basically in third quadrant, but sometimes for analysis we have seen it on first quadrant. So for that you have to select the source of this PMOS, it will give you positive current. Okay, so I am selecting this source of PMOS. So this is the PMOS source, then click on OK, then go to ADL again. So everything is fine. Now run this netlist. So actually there is error, and the error is that I have not set up that model libraries to 180 nanometer technology. So close this, go to setup, go to model library and only select GPDK 180, not this all. So I have only selected GPDK 180 nanometer now, then click on OK, then run this. Now hopefully it will give the correct result. So you can see this is the PMOS IV versus VDS plot. So actually this is on third quadrant in real, but for our visualization we analyze it on first quadrant. So I have seen the source current of PMOS. Okay, now I want to see the ID versus VDS of this PMOS for varying get to source voltage, that is VGS. So for that I have to made its parametric analysis. So again go to ADL, but before that I have to made get voltage variable. So press Q on voltage source and make it variable, that is VGS. So VGS. Now after varying get to source voltage, click on OK. So now again go to ADL and then go to tools, copy, Actually I have add a design variable VGS, but I haven't copy, so I have to copy it. So copy from cell view, then give this voltage 1.8 volt. Okay, then go to tools, in parametric analysis, add variable. So for this, for adding variable, I am selecting VGS as 1.8 volt. Then from and to, so from where to where you want to vary this VGS. So I want to vary it from 0 to 1.8 volt. Okay, and I want to see its step size as 0.3 volt. So change the step mode to linear steps, then into step size I am going to give step size as 0.3, as I always give to any video of NMOS. Now run this. So actually this is that stopping parametric simulation failed for first point. So actually it gets some error. So I have to check what kind of error it is giving. The netlist might have generated all generated corrupt. Okay, so actually when I have changed this VDC to a variable voltage VGS, I haven't saved this. Okay, so go to check and save, and then go to parametric analysis and then run it. Okay, so after that I think everything will be correct now. So it is simulating its output. Now you can see this is the plot of ID versus VDS of PMOS for various VGS. Okay, so here VGS is basically varying, so it is for 1.8 volt. So you can see here VGS is basically 1.8 volt. This is for 1.5 volt. So this is the parametric analysis of PMOS. If you have any kind of doubt, put it in the comment box. I will try to connect you, okay, via mail. Thank you.